we have to solve this question. Evaluate f dot nds where f is yzi plus zxj plus xyk and s is that we have to evaluate it on the surface. What is that surface? This surface is a part of sphere x square plus y square plus z square equal to a square, which lies in the first octant. We have to evaluate it on the part of sphere which lies in the first octant. Let me draw the surface first. So this is the part of sphere which lies in the first octant. Let me call this as x, y, z, right? So this is the part of sphere over which we have to evaluate this surface integral. The function f is given to you. So for this surface, what will be n? N will be given by gradient of s upon its magnitude. What is s equals to? S is equal to x square plus y square plus z square equated to a constant. So this will be 2xi, 2yj and 2zk, and if I take its magnitude, this comes to be, and on this surface S, this particular quantity becomes equal to a. 2 will cancel out, so this will be xi, yj, zk upon a, and if I take the dot product of this f with n, if I take dot product, this is yzi plus zxj plus xyk dot xi yj zk upon a. So this comes to be 3xyz upon a. Alright. Similarly, if I evaluate it n dot k comes to be z upon a. So this surface integral f dot nds can be written in terms of double integral as f dot n dx dy n dot k. So this comes to be 3xyz upon a dx dy z upon a comes to be xy dx dy. Now, what is the domain of this double integration? The domain of this double integration will be the projection of this surface S on xy plane. The projection of this surface S on xy planes. What will be that? What will be the projection of this surface S on xy plane? It will be a quadrant of a circle. It will be a quadrant of a circle. So we have to evaluate this double integration over this quadrant of the circle. The equation of circle will be given by, just put z equal to 0. That will give you the equation of this curve, right? This is a quadrant of a circle. This is x square plus y square equal to a square. So we have to evaluate this double integral over this region. This is R. Alright. So let me rub this. I'll rub this. So I'll have to evaluate the double integral over this quadrant of a circle. Over this quadrant of a circle, this quadrant. So I'll use the polar coordinate. I write x equals to r cos theta, y equals to r sin theta, and dx dy equals to r d theta dr. So this comes to be 3 r square sin theta cos theta. This is 3xy, right? Xy. And this is r dr d theta. R varies from 0 to a, and for a quadrant theta varies from 0 to pi by 2. So this comes to be, I'll first integrate with respect to r. This comes to be sine theta cos theta, and r4 by 4 from 0 to a. So this comes to be 3a4 upon 4 0 to pi by 2 sine theta cos theta d theta. So if I take sine theta as t, cos theta d theta will be dt. So t dt is going to be t square upon 2. So this comes to be this will be, the integral will be sine square theta upon 2 from 0 to pi by 2. So finally this comes to be 3 upon 8 into a4. Now let me consider this question. Evaluate xyz ds over the portion of the plane x plus y plus z equal to a lying in the first octant. You have to do this question. First let me draw this plane. So this is the plane. This is the x, y and z. This is x plus y plus z equals to a. So if I first of all I have to reduce this. You have to convert it to a double integral. So if I take projection over xy plane, your dx can be written as dx dy n dot k. For this surface S, this is your S. For this surface S, your n is simply the gradient of S over its magnitude. The gradient of S, what is your S? S is xy plus z equals to constant. So this is I plus j plus k upon root 3. So your n dot k comes to be 1 upon root 3. Alright. So the integral, this can be written as double integral xyz, and see this will come out to be how much? Dx dy upon n dot k. This will be root 3 dx dy. So this will be root 3. Sorry. This will be root 3 dx dy. Now see, you have a variable z. So what to do with this z? I can't write z equal to 0. See, the region of integration R is obviously this is a part of xy plane, but still, I won't write z equal to 0. I have to replace z from the equation of the surface. And I write it as, see, still we are evaluating surface integral. So we can incorporate all the property of the surface, right? So for this surface integral, the domain is S. So from this surface, I get z equals to a minus x minus y. So this comes to be root 3 xy, and what is the domain of this integration? Domain of this integration is going to be the projection of this surface on xy plane. So I can draw this projection of S on the xy plane as, so the domain of this integration is, it will be this is R. So this is x plus y equals to a. Alright. So domain of this integration is this region enclosed by the coordinate axis x and y and this line x plus y equal to a. You can just get this by putting z equal to 0. You get the projection of the surface on xy plane. So it's a part of xy plane. So this can be written as, I can find out this. So if I first take first integrate first with respect to say y, the limit of y will be from 0 to, this is y equal to a minus x, and x will vary from 0 to a. Alright, x will vary from 0 to a. Let me rub this. So this comes out to be root 3 x a minus x y dy dx. I'll put a bracket over here, minus, this is minus xy square dy dx. So let me first integrate with respect to y. So this comes out to be x a minus x y square by 2. Y is varying from 0 to a minus x, and this will be, put the bracket sign over here, 0 to a. So I don't have to write this integer sign 4 times. This will be x, and this will be y cube by 3, 0 to a minus x. This is also dx. So finally what you get is, this is root 3 by 2, this is 1 by 2 integral 0 to a x a minus x cube dx minus 1 by 3 same integral a minus x cube x dx. So what we get is, this comes out to be root 3. So this is, you have the same integral, so if I subtract it, I'll get root 3 by 6 0 to a cube dx. We have to evaluate this. See, I did this on rough work, so it comes out to be, this comes out to be 1 upon 20 into a5. So finally this will be root 3 20 into 6 120 a5, or I can write it as a5, right? Answer comes out to be this. Calculate this. This is very simple. Just open it and integrate this, put the limit, you get this integral comes to be 1 upon 20, right? You do it yourself. I did it in my rough work, right? So this is 1 upon 20. All right, so this is how you